Right. Um, a teacher asked students to suggest some experiments that could be done using chemicals found in the home. One student planned an experiment to measure the temperature change when baking soda is added to vinegar. 400 cubic centimeters of vinegar into polystyrene cup. Weigh out 5 separate grams for portions of baking soda. Measure the temperature of the vinegar. Add 1 gram of baking soda to the vinegar and stir. Record the new temperature. Add the other portions of baking soda, stirring and recording the temperature after each portion is added. So, yeah, they are determining the rate, temperature of the mixture, mass of baking soda added in grams. Right. The temperature change with the amount of baking soda added. Right. So, uh, right. So as this show, the temperature is going down, right? The student said that the reaction in her experiment was not complete. How does the graph support the experiment? Um, yeah. Yes. How does the graph suggest the experiment was not complete? Yes. What is your answer? What is your answer for that? Line did not get what? Yeah, it has not get fatter, right? The line must get fatter, right? So it must yeah. Still going down. So it means what? It means there's vinegar still in the 100 cubic centimeters of vinegar is still remaining. So that is why the temperature is going down. Only when it is constant we can tell in this experiment uh, the vinegar is still not there because the limiting factor here is what? The limiting factor must be vinegar, right? Vinegar, yes, vinegar is an acid. Yes, weak acid. Yes, her answer is correct. It has not reached a constant. Oh, the line has not become flatter, right? So she is correct. It has not become horizontal. Right. The student used the polystyrene cup rather than a glass beaker. Why is it better to use the polystyrene cup? Yeah, compared to glass beaker. Yeah, glass is a what? Polystyrene is a poor conductor. Therefore, uh, less amount of heat will escape from the surrounding into the mixture, right? So that is the reason. Polystyrene is a weaker conductor, therefore, less amount of heat will come from the environment and disturb the data of the experiment. Okay. Vinegar contains ethanoic acid. Baking soda contains sodium hydrogen carbonate. This is a reaction, right? Ethanoic acid with sodium bicarbonate. There is no color change during the reaction. Suggest one observation other than the change in temperature that could be made during the reaction. Uh, there is no color change. What is the observation? Very easy answer, right? But bubbling, right? Effervescence or fizzing. The compound ethanoic acid and the compound ethanoate is a salt. The graph show the temperature goes down during the reaction. Use this information to state the two type of reactions occurring. Uh, what are the two type of reactions? Two type of reactions are occurring. Um, what is the tell me one example, one answer for this? Neutralization. What is the other one? Endothermic or exothermic? Temperature is going up or down? Okay. Why the temperature is going down here then? Right? Neutralization and endothermic, right? Neutralization as per the graph, as per the data, it must be endothermic, right? Thermic and neutralizations. Now you will in the A classes you will learn why the reaction has become even though it's a neutralization, why it is an endothermic reaction, right? So here there we are teaching you why it is ethanoic, so it is a weak acid, right? So its dissociation is weak, so therefore to dissociate H plus, right? Uh, to dissociate H plus from ethanoic acid, heat has to be absorbed from the surroundings, right? So heat had to be absorbed from the surrounding to completely dissociate the ethanoic acid because ethanoic is not getting dissociated completely because it's a weak acid, right? So in the A levels you are learning, right? Since ethanoic acid is a weak acid, to completely get itself dissociated, it needs to absorb some amount of energy from the surroundings. So from the surroundings, energy is absorbed. We are measuring the temperature of the surroundings. So that is why temperature is going down, right? Okay. So that, therefore, it is an endothermic reaction. Yeah, as you said, neutralization reaction must be exothermic, but here it is a weak acid. That is a strong acid, right? For weak acid, this could happen, right? Okay. Uh, Not only ethanoic acid, and this is also a weak base. So it's a weak base, weak acid reaction. So that is why it is an endothermic reaction. Strong acid, strong base reactions, as you said, it is exothermic. It is a weak acid, weak base. So it could be an endothermic reaction, right? So as per the data, it is endothermic. Is it understood? The complete energy level diagram by showing the products in the reaction. How do you draw it? These the reactants. Where do you place the products? Under, right? Because it's endothermic. right? Have you sent it? You have sent it, right? Uh, your one is okay, but you're right. All the products, right? Not only one thing. You have written down only one product. So that is not the only product. So what is happening with the others, right? So the effervescence, carbon dioxide is released. So everything must be there. Otherwise, your answer is not complete. You can't just. This is like a reaction. So there must be reactants and the products, right? The products are having less energy, and it is right. Complete energy level diagram. So in your answer, where's activation energy? Either it is endothermic or exothermic, there must be you must have the activation energy, right? So EA activation energy, and here from here to here we have it is delta H minus. Sorry, it is an endothermic reaction. My bad. So therefore, energy is absorbed. So product label must be like this. So all the products must be written. This endothermic reaction CHC double O minus Na uh, carbon dioxide plus water. Right? Yeah, it is balanced, right? Carbon dioxide gas, H2 liquid, aqueous. So this is where you have the activation energy EA, and here it is an endothermic reaction. So delta H. Right? Um, it is an endothermic reaction. So these are the reactants, these are the products. Okay. So you must label the activation energy with the correct curve, and also you must mark the enthalpy delta H delta minus. Right. Let's move on to the next one. So you have to label it as delta H. Yes, we have done that. Student repeat the experiment using the same method with a different sample of vinegar. She recorded these results. Volume of vinegar, heat energy change. The equation is also given, right? Volume of vinegar, temperature, right? Need to calculate it. Volume of vinegar is 100 cubic centimeters. 4.2. So 4.2 is what? It is given in grams, right? Joules per Kelvin per gram, right? And the mass of heat energy, right? And the temperature change is what? The difference between this. So it is a positive or negative? Initial and final, right? Final temperature, end temperature is 13.2 minus 18.7. Right? It should be the other way around. 18.7 to 13.7, 13.2, right? Temperature at the start, temperature at the end. Initial minus final. My bad. 18.7 final temperature minus initial temperature 13.2. Right. So you must get a positive value in joules. Right. 4.0 is given in joules. So what is the value you got here? You must get when you multiply this. It's a different. We are talking about different experiment. Right? A student repeated their experiment using the same method with a different sample of vinegar. So 13.2 minus 18.7, right? Final minus initial. So you are getting a negative value here. So the temperature change is 5.5, negative 5.5. Uh, so your answer you are getting in, and here you have to make an assumption. It is 100 cubic centimeters. 100 cubic centimeters. You must assume what the density as 1 gram for cubic centimeter, right? Uh, so here the answer you must get around negative 2302 joules. 2300, 2300, or something around this. Okay. Yes. So is that the value you got to put up? So it means in the second experiment, this time she got it as what? Exothermic, right? This time it is exothermic. Previous it is endothermic. So it's a different method. So you must write in joules. The student wanted to calculate the amount in moles of ethanoic acid in vinegar. Apart from the volume of vinegar, what other information would she need to be able to calculate the amount of ethanoic acid? She student wanted to calculate the amount in moles of ethanoic acid in vinegar. Right. Amount from the volume. What other information is needed? What is the other information you need? The volume is given. What is the other one? Molar mass, concentration, right? Other information is the concentration. Concentration multiplied by volume is equal to number of moles, right? Not the molar mass. They has nothing to do with molar mass, right? Because if the volume is there, the other information you need is concentration. Molar mass is needed if the other information is what mass. They are not talking about the mass of vinegar, right? And the vinegar is either aqueous form. right? So if we are talking about a solution, so when we are talking about the solution, we are not talking about a mass here. So your answer is correct. If you are talking about a solid and the given one of the given information is if one of the given information is the mass, then your answer is correct. Then if you know the molar mass, you can find the number of moles. But here, one information is volume. Given that you know the concentration, we can find the concentration multiplied by volume is equal to number of moles. Okay. Have you done other one? No, so I have shared another few papers with you. I couldn't hear you. Okay. Right. Tell me once you're done. Right. I'll give you 5 minutes to complete it. Right. Our next paper. A teacher discussed with her students whether the boiling point of organic compounds are related to the size of their molecules. The students suggested measuring the boiling points of some organic compounds using this apparatus. Thermometer, organic liquid. Okay, Bunsen burner. The teacher said that their suggested method was too dangerous. She recommended using the apparatus shown below instead. Loose fitting cover, organic liquid, hot plate, right. This one is dangerous. Yeah, it may get, uh, what do you say? If the organic liquid is flammable, it will get what? Combusted quickly and will go in flames, right? This way, cover fitting. Yeah, now here it is not getting burned. Why? No, it is not exposed to the environment, so therefore no, uh, it lacks oxygen to get burned quickly, right? So it is not getting burned. Suggest one reason why the apparatus is better than the student's suggestion. Why here? Tell me. Bunsen burner here it is directly, and here it is on a hot plate. So here it is a loose fitting cover. Anyways, in the first one, yeah, it is directly exposed into the higher temperatures. And other thing is it is getting exposed to the outside environment here, and it is getting a lot of oxygen and it is getting burned. In the first apparatus, it may get burned and go into flames, right? Second one, it will not get burned because it is not exposed to much. It is exposed, but it is not getting much enough oxygen to get burned itself, right? Right. Because if the organic liquid is flammable liquid, then it could get burned. Or you can talk about being vaporized also. Now let's say it is not getting burned quickly, but if it is vaporizable, this one is before you are heating it, it is getting vaporized. Or the vaporization is getting increased as you provide heat from the bottom of the tube. But here, let's say it is getting it's a very volatile compound, organic compound. Though it is volatile, since it is covered, it is not going to get into the environment. So therefore, you can do the experiment. Two things: either being flammable or either being very volatile. So if it's a volatile, very volatile compound, it may get leaked out from the first one. No, if it is flammable, it will get combusted, and it is going to be dangerous. Being vaporized is also a dangerous thing actually, right? If it is a harmful liquid, then they will what breathe it and inhale it, so that inhalation process may be kind of risky for the person who is doing the experiment. Student use the apparatus recommended by the teacher to measure the boiling point of 5 alcohols. Their results are shown in the table. Plot a graph of the data in the table on the grid. Draw a straight line of best fit through the points. First of all, you must mark the data points and then you must draw a line of best fit. Right? It must be a boiling point relative formula mass. Um Straight line, they are talking about not the curved line, straight line. They are also given it like that. Right? Practically, you must not get a straight line, it must be a curved one, right? There must be a curvature. But here they say draw a straight line. So you must find the a line of best fit that is going through most of the points, and it is symmetrically going between most of the data points, right? Um, so you must mark them on the gridboard correctly, and the line must go through majority of the data points. If it is not going to the majority of the data points, it must be going in between the data points evenly, right? For example, like this. If you couldn't find the, if the line is not going through many of the data points, and if you can't draw a line like that, then at least it must go through in between the scattered data, so they are in two sides of the line equally scattered. Right? It should go symmetrically through the scattered data points. Right? Describe the relationship shown by your graph. What is the relationship? What sort of relationship is that? Okay. What sort of a relationship is it? Yeah, the is it a, okay. Boiling point is there. With the mass, boiling point is going up, right? So it's a straight line, something like this, roughly. So it is a. Uh, so you must write the answer this way. Uh, Boiling point is what? Proportional to relative mass. Relative formula mass, right? It is boiling point is proportional to relative formula mass, right? Or it is a positive relationship actually, not a negative relationship. Positive relationship between boiling point and relative formula mass. Okay. Use the graph to predict. the boiling point of the alcohol that has a relative formula mass of 74. So you have the graph. What is the value you got? You just easy, right? One of the easiest. For example, if the line is going like this, so what they're saying is 40, right? 74. So from this, we are calling in science as the calibration plot. It's a calibration line. So let's say if it is 75, right? You draw a straight line from 70, which is 75, 74. Okay. From around 74, 5. Okay, you are drawing the line, straight line. The point where it is intercepting this line, you draw a horizontal line. So with this value is the predicted value for the boiling point of the given compound of given compound or the given relative atomic mass of the compound with an unknown boiling point, right? So the boiling point is unknown, but you know the relative atomic mass. From the relative atomic mass, you can find the boiling point of the unknown compound. Okay. Which of the alcohols A, B, C, D, E is the least volatile? Least volatile means one having the highest boiling point, right? So as per the data, which one? Higher boiling point means least volatile. A, B, C, D, E, right? So based on your graph, what is the answer you got for the boiling point of the unknown compound, right? With the relative formula mass given. Yes. What is the value you got? Yeah. I'm asking now if you are done it, you must have an answer for this thing. What is the answer? Yes, it's after something. So today I'll end the class for now. We have to I don't know much time. Uh, how far you have done this in the paper? Let's see. Let's go fast. The reaction is carried out at a pressure. The carbon monoxide, hydrogen are used in the manufacture of ethanol. The reaction is reversible and can reach the position of dynamic equilibrium. This is less organic, right? The reaction is carried out at a pressure temperature. State two features of the reaction that is in the dynamic equilibrium. What are the features? Does not change, right? The reactant concentration and the product concentration is not getting changed. Rate of forward reaction and the backward reaction is happening at the or it is equal. Or the rate of forward reaction is as same as the rate of backward reaction. How would a decrease in temperature at constant pressure affect the amount of methanol in the equilibrium mixture? How would a decrease in temperature at the constant pressure uh, right? How would the decrease in temperature? What is your answer? Decrease in temperature. Forward or backward reaction is favored. Yeah, this is actually physical chemistry, right? Yeah. So the when after we covered that part, physical chemistry equilibrium, you can answer it actually. I'll tell you in brief. Here the forward reaction is what? Generating heat or releasing heat, right? Then the backward reaction must be opposite, absorbing it. So there's a principle called late Chatelier principle. The late Chatelier says if the system is in equilibrium, if you do some change to the system, like externally, externally, you are doing by an external force, you are changing the temperature or changing the pressure or either trying to change the concentration of either reactants or products, right? But the thing is, system itself is later trying to cancel that effect. For example, if you increase the temperature, system tries to decrease the temperature in the system itself. If you increase the pressure, system tries to reduce the pressure in the system by itself. If you change the concentration, the system is trying to adjust the equilibrium position of the equilibrium and try to cancel off that effect. Now in this case they have what? Uh, Externally they are decreasing the temperature, right? Externally they are decreasing temperature. By an external force they are decreasing the temperature. Maybe they are putting it in a freeze or something. So decrease the temperature means system is going to lose the temperature. So in that case, since the forward reaction is exothermic, right? By favoring the forward reaction, system is trying to increase the temperature of the system because from externally we are trying to decrease the temperature. So therefore, system forward reaction is favored. When the forward reaction is favored, the equilibrium position, right? Equilibrium position moves forward, right? So when the equilibrium position is moving forward, you have more products than the reactants. I'm talking about a comparison. Before increase in temperature, before decrease in temperature and after decrease in temperature. So it means before decrease in temperature has more reactants. After reducing the temperature, you have less reactants. Other way around the products also. Before reducing the temperature, you have more products. We have less products before reducing the temperature. After reducing the temperature, since the system is favoring the forward reaction by moving the equilibrium position forward, you have more more products or less products? More products because forward reaction is favored. Right? More products means you have more what? Methanol. You have more products. More methanol is made. Why? The reason is since the forward reaction is exothermic, system is the equilibrium position is shifting to the right hand side, producing more products in this which is methanol. Okay. How would an increase in pressure at the constant temperature affect the amount of ethanol in the equilibrium mixture? Right? How would the increase in pressure? Increase in pressure means in the forward reaction, less amount of products are formed. The backward reaction, more products. More products means more gas particles, gas molecules. More gas molecules means more pressure. The forward reaction, you are less gas molecules, right, are produced, so less pressure. So if you reduce the pressure, if you increase the pressure, to reduce the pressure of the system, total pressure of the system saves the forward reaction, then the amount of ethanol produced is going to get low, right? So in that case, ethanol is more ethanol is produced, right? Because the forward reaction is favored. Okay, so we will end the class for today, right? And we can continue next day, right? Okay, bye bye. Take care.